Alright, so in our previous lesson, we talked about the Pythagorean trig identities and how you could use them to simplify stuff. And now we're just going to look at simplifying trig identities. So this is bringing all this stuff together. It's also going to be a lot of math skills that you've used since kindergarten to now. So it's a lot to review. It may be a little overwhelming. Don't feel bad if you have to rewatch the video multiple times, or you can look at the extra resources that I've given you. There's other videos of different teachers teaching you some different problems, so just put some extra work into it. Ask me for help, and we'll get through this together. So your learning target is I can simplify trig identities. Alright, so over here, these are your quotient identities that you need to get used to. I don't know what happened to these. It had a title. So these are your reciprocal identities. And this is what we looked at yesterday. These are the Pythagorean identities. So these are, I didn't list them all. Like if you took the first one, you could move the sign over and just get cosine by itself. So you can rework the problems in like an equivalent form, and they still might be. So anytime you look at stuff being squared, you're probably going to use these. Anytime you see reciprocals, so like 1 over sine, 1 over cosine, like fraction form, probably going to be looking at these. And anytime you see tan or cotangent and you're trying to get like a sine or a cosine to cancel out, you're kind of looking at the quotient identities. So that's how you know when to use these, and just practice makes perfect. Okay, so we're going to use the fundamental identities, the ones we just talked about, to simplify the following trig problems. Okay, so if I look at the first one, I have sine squared x and then cosecant x. And so the first thing that I notice that's going on, so I see the sine squared, but it's not sine squared plus anything or sine squared by itself. So I'm not going to be using a Pythagorean identity, but I do know that this is a reciprocal identity. So I'm going to replace the cosecant with 1 over sine, because that's my reciprocal identity, and then I have sine squared x. Okay. So then, I should know that anytime I have sine squared x, that's really just sine, like 2 of them, and that's on the top of a fraction, and then you have 1, and then a sine x on the bottom, and you should know from previous math courses that you can cancel out one of these. So only thing I have left is sine x. So that is how I simplify that. Alright. I'll look at the next one. So I could rewrite cotangent as 1 over tangent, but there would be nothing to cancel out because I really want to get rid of that cosine. So if I rewrite cosine as the quotient identity, then I can simplify. If I rewrite the cotangent as the quotient identity, then I can get rid of the cosine. So let me show you what I'm talking about. Cotangent is the same as cosine x over sine x. And then on the bottom, you had divided by cosine x. Alright, so for previous math courses, this is really what it looks like. So you have this that you changed, and then it's being divided by cosine x. So whenever you have a fraction being divided, that's when you use same, change, flip. So you keep the first one the same, you change it to multiplication, and now you're going to flip the second fraction. So now when that happens, cosine on top cancels out a cosine on bottom, so what you have left is 1 over sine x, and that is a reciprocal identity. 1 over sine x is the same thing as cosecant x. So that is my most simplified form. Okay, so in the first one, we used a reciprocal identity. The second one, we used a quotient identity and then a reciprocal identity. And now, based on process of elimination, we're probably going to be using a Pythagorean identity and something else. Okay, so the first thing I notice is on the bottom, I have this cotangent squared and then being added, 1. So anytime you have something squared and something's being added or subtracted, that's probably going to be a Pythagorean theorem. I mean, not a Pythagorean theorem, a Pythagorean identity. So if you look at this bottom one, so the cotangent isn't isolated, but I could get it isolated. So remember, and you can go back and look at the previous lesson, but the cotangent squared plus 1 is equal to cosecant squared. Alright, so that's what I'm going to use. So I'm going to replace this, 1 over, and just change it to cosecant squared. Alright, and now we're going to use a reciprocal identity because 1 over cosecant is equal to sine. So 1 over cosecant squared would be equal to sine squared x. And that's our most simplified form. Alright, so let's look at these. It's hard to know where to get started, so sine I can't really do anything to, but I can change secant to 1 over cosine. So that's what I'm going to do. So if you'll notice, what you have is sine on top and then cosine on the bottom. And according to our quotient identities, this is the same thing as tangent. So that's what I do. Alright, so for the next one, here's some stuff being squared and there's subtraction involved. So that's a Pythagorean identity. If you go back and look, this is the same thing as 1. So I have sine x and then 1 over tangent of x. And 1 times the sine of x is just sine x. So really this is all I have right now. Don't really need to do anything with sines usually, but tangent I can rewrite as cosine over sine. So let me show you what we have. The sine of x on top, and then tangent is sine over cosine. So from previous math courses, I really know that what's happening is this. And anytime there's like division and a fraction involved, that's when you use same, change, flip. So I'm going to keep the first one the same. I'm going to change this to multiplication, and I'm going to flip the second fraction. Oh, and I didn't flip the second fraction. Hold on. Now let me flip it. So what you have is a sine on top and a sine on the bottom. They can cancel out. So all you're left with is cosine x. So that's the most simplified version you can get that to. Alright, so if I look at the last one, here's something being squared and subtraction going on. So that's a Pythagorean identity. And when I look at my sheet, this is the same thing as cotangent squared. So here's what I have left. Okay, I can rewrite cotangent as cosine over sine. So cotangent squared would be cosine squared over sine squared. So I'm just going to rewrite this. And then everything else I'm just going to bring down so you can see it. And then notice what you have is sine squared on top, sine squared on the bottom. So really all you have left is a 2 in front and then a cosine squared x. There's really no further you can go with that, so it's complete. Okay, so here's what I'm looking at. Whenever I see tangent, I usually know to go ahead and change that to sine over cosine. And then if I ever see something like secant, cosecant, or cotangent, I usually know that I'm going to be doing... Okay, Sorry, my phone interrupted. Okay, so I can rewrite secant as 1 over cosine. And then I have sine x divided by, and I can rewrite tangent as sine over cosine. So let me rewrite this a little bit differently. So we got this part in purple. We got sine, and it's being divided by sine over cosine. So once again, we have some division of fractions going on. So we're going to keep the first one the same because it's fine. And then we're going to do same, change, and we're going to flip. Okay. So watch what happens. So there is a sine on top, a sine on the bottom, a cosine on top, a cosine on the bottom. The only thing left is the number 1. That's how that one simplifies. Sometimes it's that easy. If I look at the next one, automatically I see some stuff being squared and some addition. So I know that that's a Pythagorean theorem. That becomes 1. And anytime I see a fraction going on like this, I should know that that's a reciprocal identity. So 1 over sine is cosecant. So 1 over sine squared will be cosecant squared. Usually when you see tan and cotangents, you're going to be using those quotient identities. So that's the first thing I'm going to do. I'm going to rewrite tangent as sine over cosine. And then obviously we're going to be dividing, and I'm going to rewrite cotangent as cosine over sine. And notice there's division of fractions, so we're going to do same, change it to multiplication, and we're going to flip the last one. So what we have right now is we have sine squared on top because there's 2 of them, cosine squared on bottom because there's 2 of them, and then we're going to use the quotient identity again. So we know that sine over cosine is tangent, so sine squared over cosine so sine squared over cosine squared would be tan squared. And that would be it. Okay, so now it's going to get a little bit harder because we're using skills that we've learned in previous math courses while we're doing all this stuff. Okay, so for these 2 examples, we're going to multiply first, and then we're going to simplify using the fundamental identities. So this is a binomial times a binomial, which is when you use the distributive method, or you can use the FOIL acronym if you need to. So when I do the first 2, cosecant times cosecant is cosecant squared. When I do the outer, cosecant times cotangent is just cosecant and cotangent. I'm going to put them in alphabetical order. Alright, and then I'm going to do the inside. I have a negative cotangent times cosecant, so it's going to be negative. And once again, I'm going to put it in alphabetical order. And then the last 2, I have negative cotangent times cotangent, so negative cotangent squared. Alright, if you'll notice, when I put them in alphabetical order, I can see a little easier that those 2 are like terms and they cancel each other out. So this is what I have left. So all I did was I used the FOIL method from Math 1, and now I'm going to use my my Math 4 properties that we learned this year. So stuff being squared and subtraction, that should clue you in to use a Pythagorean identity, and this Pythagorean identity says that this equals 1, and that's what you do. Alright, so if I look at the next one, anytime there was something outside of a parentheses, my entire math career, you've always distributed. So that's what you're going to do. So tangent times cotangent. Just write it like that. Or if you want to put it in alphabetical order and you want to put cotangent first and then tangent, whatever you want to do is fine. And then the last one, tangent times tangent is tangent squared. Alright. Next, I'm going to use the fact that cotangent is the same thing as 1 over tangent. I'm going to show you what happens. So if we have tangent x, which is 1 on top and 1 on bottom, everything cancels out. So 1 plus tangent squared x. this is something being squared and addition, so look at your Pythagorean identities. This is actually equal to secant squared x. Okay. Alright, so now let's look at what we do when we factor. So the first thing we'll do is we'll factor each expression. If you don't remember how to factor, it's not good because you did it in Math 1, Math 2, and Math 3. You could stop the video and go watch some factoring videos if you needed to. Okay, so the first thing that I notice is that both of these have tan squared x in them. So that's going to be my GCF that I'm going to take out because that's how you factor. So when I take out tan squared x from the first thing, the only thing's left is a 1. And then from the second thing, the only thing's left is cotangent squared. That's how you factor. If you don't know how to factor, stop what you're doing and go learn how to factor. The next thing I notice is that this is actually a Pythagorean identity. So I'm going to change this to cosecant. So I have tan squared on the outside, and then I have cosecant squared. Okay. The next thing I'm going to do, and this is pretty difficult, this one I'm going to rewrite as a reciprocal identity. So cosecant is the same thing as 1 over sine, so cosecant squared would be the same thing as 1 over sine squared. Because I want some sines to cancel out, I'm going to rewrite tan as sine over cosine. So because it's tan squared, it's going to be sine squared x over cosine squared x. So then you should see what happens. I got sine squared on top, sine squared on the bottom. The only thing that's left is 1 over cosine squared. And that is a reciprocal identity. So 1 over cosine is the same thing as secant. So 1 over cosine squared would be secant squared x. Okay, so using the stuff from previous math courses and then using those identities that we have learned and putting it all together. It's a little overwhelming, I understand, but this is how it works. Alright, so for the next one, the top is called a difference of squares. So it's going to become 1 over cotangent squared, 1 plus cotangent squared. If you don't remember what difference of squares is, go watch a video on it. On the bottom, I have 1 minus cotangent squared. So I got this on top, this on bottom, that can cancel out. I'm left with 1 plus cotangent squared. There's addition and a trig identity being squared, so that's a Pythagorean identity. So this becomes cosecant squared x. Alright, and then 2 more. Okay, so this one I think is the most difficult because it's from Math 3 when we did rationals, which is just a bunch of fraction stuff. So I don't know if you remember, but the only way you can add or subtract fractions is for them to have the same denominator. So the first one has secant minus tangent, and then the second one has secant plus tangent. So whatever they don't have, I'm going to do to the top and bottom. Okay, so the first fraction does not have this as its denominator. Okay, so I'm going to do it to the top and bottom. The second fraction looks like this. It has the plus, but it doesn't have the minus that the first one does, so I'm going to do that to the top and bottom. Okay, so whatever it's lacking, you do it to the top and bottom. Now if I look at just this fraction, so the top is going to be secant x plus tan x. And the bottom, if you were to FOIL that, would actually give you this. Alright, second fraction. When I simplify, I get this on top. And then the bottom looks like that. So now they both have the same thing on the bottoms. So they're just going to have the same denominator. That's what we want it to happen. And then on top, my tans will cancel out. So I actually have 2 secants. Okay. Then notice that this is a Pythagorean identity. So I'm going to change that to 1. So 2 secant x divided by 1 is just 2 secant x. Alright, I'm going to pause the video and I'm going to erase this. If you need the video, then pause it. Okay, so for the next one, I'm not going to worry about adding or subtracting first. I'm just going to get rid of, let's see, I'm going to change this to cosine squared over sine squared. It's being divided by cosecant, and then I have that first cosecant x. Alright, so this part, fraction and division, we're going to use same change flip. Same change flip. And I know that this becomes the same thing as sine. So I have this. This one's pretty tricky. Okay, so what I can do is I can take out one of these signs. So what I have left is cosecant x minus cosine x over 1 sine x. Alright, so here's another thing. I know that cosecant is 1 over sine. Okay, so that was a lot of manipulation, but now I have two fractions with the same denominator, which means I can actually do the stuff now. So the denominator is going to be sine x, and on top I'd have 1 minus cosine squared x. This top is a Pythagorean identity. It's the same thing as sine squared. On the bottom I have a sine x. So if I had two sides on top, one on the bottom, one would cancel out. So I just have 1 sine x. Those last two are super tricky and super hard. So don't feel bad if you got a little confused. Rewatch the videos, use the extra resources, do whatever you need, ask me for help, find a study buddy, I don't know. Figure it out and you'll be fine. Okay, let me know if you have any questions.